Boa tarde a todos. Vamos dar continuidade?
Let us continue with the event. Good morning. We have Hamilton Nogueira of purcon, multiple sustainable applications of PU in the building trade. Thank you very much. Good morning, everyone. I hope you can all hear me. I'm going to be talking a little bit about purcon and our initiatives and products in the industrialized construction industry. First of all, I'd like to highlight that purcon is a technology company. We produce chemicals in the PU chain, polyurethane chain, and we are hyper specialized in innovation. We are a solutions factory, so to speak. And I'm going to be talking about solutions and about sustainability and the circular characteristic of the products we place on the market. And I'll be emphasizing the construction industry, above all the industrialized construction segment of civil construction. I'm just about to play a video. About purcon and our systems, you'll see in the video and in the presentation that we're a company that needs to understand what customers' requirements are. What do we do on a daily basis? We receive market inputs from our customers who need a product from our production chain based on our type of technology, which is PU. And then we introduce products that will meet that or those specific needs. So we produce specialized solutions to meet customers' requirements. You'll see from our track record that we've taken part in many technologies that were introduced into Brazil over the last 20 years. Above all, the replacement of GHGs as expansion gases to environmental friendly gases. We were pioneering, and the UN recognized our work, which was the start of the replacement of GHGs in expansion gases. Our DNA is chemistry, but we're very solutions oriented. There's no such thing as chemistry without a customer who needs that chemistry for their own special purposes. So our DNA, we have a circular vision. What we see as being value is to seek for all the company's processes to be circular. Everything that we produce, we want to make it so that it doesn't create any environmental liability, but always goes back into the production chain somehow or other. We want to drive the circular economy in all processes involving polyurethane, and we want to be a catalyst for reducing greenhouse gas emissions. In all of our talks here at this Congress, we're talking about reducing the carbon footprint. So what we do to meet these goals is to first of all work with renewable raw materials. So new carbons, non-petrochemical carbons for our chain. So carbon that nature itself can circulate. We work strongly in recycling. Our technical director, Gerson, spoke yesterday about the chemical rather than physical recycling of polyurethane. And we've been acknowledged worldwide for that work. We seek solutions and partnerships. Very often we can't do everything that needs to be done, so we develop partnerships to try and understand needs. We wish to eliminate industrial PU wastes. This is essential because the circular economy means coming back into the chain with the waste in some way or another. And that leads to a lower emission of CO2. That's the main objective, not to generate environmental liabilities. So in the construction business, any kind of construction starts with the product step, the stage where we manufacture the material that's going to be used in the building process. Any polyurethane, for example, for insulation, made by us, undergoes a production process within purcon to then arrive at the construction process, which we will talk about. Let's say industrialized construction, which is the goal of the talk, and then eventually it'll reach the use step and the end of life step. So where we are using renewable source material and we use recycled materials. So we begin to contribute to the circular chain at the production process. In the building or the construction process, we're managing to contribute by these products producing less waste. And then eventually we get to the use stage. So where does the purcon product enter? Well, these are the technologies that are built into civil construction that use, for example, or that provide energy efficiency, which is essential because then we help bring down the carbon footprint, not only in our own product, but the world's carbon footprint and efficiency. Less energy is less emissions and fewer products producing CO2. And the end of life stage, the building, the construction, or whatever the product is, it reaches the end of its life. And how do we bring it back to step A1 or A2 for the recycling step within construction again, or production again? And this is how we do this. The slide is going to talk about our structure, how purcon works for civil construction or for the making of mattresses or sandwich roof tiles or for skateboard wheels or surfboards or whatever. This is our work. We have chemical engineering, which creates the technology from a renewable source, for example, using a material that is in nature and bringing it into the production chain. There's no point in having a chemical if I don't know where I'm going to use it. How will I make it processable or transformable into a product? So that's product engineering. And then process engineering. For the time being, all of this is within our own four walls, but now I need to make it work in my customer's home, and there's a process there which also has to align with what I'm providing. So this client purcon interaction happens every day, and our goal is to make the client's process work and deliver the product they need to the client. It'll only happen if the circle works. And then that's why we are seeking green solutions from renewable sources within the circular economy. And then it's not only about support to keep the product always up to date, but also to bring this product use into an institutional environment. Partnerships, for example, to present the customer and their product to or introduce them to the market in favorable conditions for all the stakeholders. That's very good. So purcon has a lot of circular technology embarked, recycling renewable sources, but this cannot just be talking the talk. It cannot just be a PowerPoint. It has to be documented. There's no point in a constructor or a builder who wants to use our material if they are not willing to use the material in such a way as to obtain certification or funding. So we work with traceability and transparency throughout our production cycle in order to reach this step at the bottom of the slide, where we have sustainability based on ISCC plus certification. That is a certificate that says that the system, the product that purcon is delivering, it really has the amount of renewable energy, of lower carbon. You can use this product, and when you present this document to a company or a certifier, then you will receive the right score owing to that material that you're including in your technology. So here's an example of one system, which is Biorigi Ester, which has 64% of a polyol, which is 64% renewable. This is not a calculation we carried out. Beta Analytics carried that out. How do they know it's 64%? Carbon 14. Everyone's heard of carbon dating, for example. When you carry out carbon 14 dating, you discover how much in percentage terms of carbon comes from petrochemical sources, comes from fossil fuel, and how much comes from renewable sources. Old carbons, petrochemistry. New carbons, renewable sources. This is essential because the analysis enables us to come to ISCC plus, and then that helps us feed the building company. That document is used by them or helps them seek their own certification, like LEED, Aqua, Casa Azul. It's a Brazilian seal. The Brazilian Caixa Econômica uses that, and also Procel. So all of these types of certification today are required, and they require a valid document to underpin them. So it's not just talking the talk. We need this traceability so that we can be auditable in the process. Now I'm going to talk about industrial construction. What do I mean by that? It means building outside or building part, perhaps even most of the building outside the building site itself. It's a trend. It's an important trend, and if you're interested in getting to know more about it, I'll just give you a highlight about what this type of industrialized building means. Because if you're not familiar, you will soon get to know this. These are constructions such as modular constructions. Modules are well known as a form of construction. What benefits do they bring? There's an exponential increase in productivity and efficiency, because a lot of it is carried out in the manufacturing plant, and then take pieces that are virtually ready from the plant to the building site. So, for example, weathering can be avoided because so much is built in the manufacturing plant. A substantial increase in speed speed, in the speed of delivery of projects. For example, building a wall out in the field on site takes much longer than building one in the factory. Reduction of wasted time and materials, a great deal of materials efficiency. There are some other important benefits. We've begun to develop some products on a repeated basis. Where you have repetition, this leads to economies because then you have better process control. You can carry out these tasks more efficiently. The more of that one does, the better the results. You improve costs and deadlines and quality. It values and enhances the value of the supplier professionals within AEC. This type of construction is no longer it doesn't use bricklayers so much or just mere builders. It involves professionals who work within an industrial context. What does purcon do in this industry? We have a number of types of technology that we deliver to the industry. We have our own nomenclature for a lot of the pieces, but for all of the areas. So, for example, waterproofing, thermal insulation, sound insulation, soundproofing, this is all embarked within or built in increasingly and also increasingly efficiently. And always based on our main goal. We're not trying to, our goal is not industrialization, it's sustainability. So we have structural adhesive primers and polyurea, pour and pier sprays and pour and pier plates or sheets. These are the technologies that we build in today. And now to talk about our bio line. What is the purcon bio line? All products that have within them an amount of recognized renewable source matter, we call them bio because it covers materials from sustainable and renewable sources, and also acknowledged by Beta Analytic, as I said. So we have adipur, the material that goes into that aspect are called bioadipur, bioadipur, and so on. All of these materials are called biocella, biosemi-rigid. And now, just to talk about certain products, polyurea. What it is a high-performance waterproofing or weatherproofing. It lasts above 30 years. It's applied by spray, virtually instantaneous drying and curing. It's a spray you apply and 1 minute later you can walk on it, and its elasticity is up to 500%. So we're talking about an industrial setting. We don't want to be watching, as it were, the paint dry. We want to have it ready quicker. So things have to move fast. Polyurea enters this segment, and it is already performing strongly because weatherproofing and waterproofing are correct with the speed, quality, and durability that market requires. Then we also have closed cell pier spray, as you see in this video. It's a spray, the feature of which is that it meets IT10. So these are settings that need certified materials in terms of fire retardance and fire resistance. So our materials for internal settings compulsorily meet IT10. They have excellent thermal properties. They'll give you twice the amount of thermal insulation, that the other materials normally used for that insulation provide. It's an air and water vapor barrier. It can help isolate the home against the introduction of water. We are not using bricks anymore, so it avoids damp. So we have a volume inside the wall. We need to be assured that the moisture from outdoors will not penetrate indoors. So the per spray, which is our unique technology, is used for this reason, and what it does is it delivers a thermal and quality result to the client.
This was closed cell. What about open cell? Open cell is a material whose purpose is to have acoustic insulation. I use open cell in partition walls in the household and construction in the field when we work with light steel frame, dry construction systems, and I use the open cell spray to bring to that wall some very important characteristics. First one, to meet the IT10, to meet the Brazilian standards for noise, NBR 15575 for noise, to eliminate the talk effect. If you have seen a dry wall, you see that effect seems that it's a bit fragile. Using this technology, all the volume of the wall is filled, so you don't have the echo caused by talk. It doesn't stretch or shrink. It's been used in the US for many years, and it's a product that gives a working life greater than 80 years in the US market. And it takes 100% of the internal volume, which is critical for you not to have moisture pockets. It's important not to create cracks or fissures because there is loss of thermal efficiency, loss of acoustic efficiency, and creation of infestation in the wall because there will be microclimate inside and there could be infestations. This is a critical material for this type of application. One very important system, there will be one other talk about it, is the SIP, the structural insulating panel. I put it standing on the field. In addition to there being savings on the structure of the design, it's a self-made system. In the works, I have a structural element with thermal insulation, which is very competent. This is a major market that is growing a great deal in the world, and in Brazil, it's not any different. As I said, the structural element is a thermal insulation in PIR. There are several finishing substrates, plywood, cement plates, and it's processed. It's made in the manufacturing plant. Going back. Too much. I'm sorry. This is a case we would like to present to you because we always understand that it's important to have a bit of adherence to what we present with the reality. Everything we're talking about is used is implemented. And here we have some customers, the Caesar Group. It's a company that manufactures modules. It's a builder of modules, pieces of a building. A module could be a house, or a modulus could be a piece of a hospital, piece of a building. Module is manufactured in a manufacturing plant, 100%. Walls, flooring, ceiling, electrics, piping. It's all built in the plant. It's placed in on a truck to be taken to the place to be installed. So it's something that I do inside my manufacturing plant. It's very innovative from the point of view compared to traditional construction, but that's a reality for a long time. And the Caesar Group has been using several technologies that Purcon developed. I'm going to show you a quick video to show you how important that is to us with the Caesar Group. And then I'm going to give the floor to Gervasio, who is our colleague who did all this implementation, that followed the implementation, so that he can talk about that step of the works. Sins and Virtues, Capital Sins and Virtues. This series is based on real facts. It talks about the main vices of conduct of men, including in business. It shows antidotes for these sins. Greed. Gluttony. If you this thing of wanting to everything to devour at any cost, it's not about us. It's good to share knowledge. According to Caesar, to start sales of adhesives, 2021, Tech Day, Purcon, and Caesar Group to show all the solutions for civil construction. (2021) closed the deal to develop a system, a construction system for a more innovative and sustainable vision. 2023 started the project for verticalization with internal production of the PIR IT-10 plates. This is an example of a turnkey process with moderation in a platform that is complete of solution in polyurethane. Moderation, this is the soul of Purcon. It's circular. Purcon. It's a sin not to think about the future. Thank you very much. I'm going to give the floor to our CEO, Giuseppe, and to our colleague, Gervasio. Thank you, Hamilton. It's always a pleasure to work in projects like this. What's great about polyurethane, it's so versatile. We learn every day. We learn with the customers. Principle of circular economy is contribution. We have put together this journey with Caesar. They started with container construction systems. It's a success. You can ship all these technologies that you've seen, polyurea, closed cell, for modular construction, now going to bio PIR. and low carbon technologies, low impact, because the cycle of industrial processing is to deliver value at the end of life. We have to follow how the hub of polyurethane in the entire journey of construction, eco-design, not to think only about the efficiency of the product as it lives. The more efficient it is, reducing energy, materials, but also thinking about the end of life, going back to have raw material being raw material generating value to the market. Unfortunately, Cesar and Paulo Marçal, who are scheduled to be here with us to clarify some issues, couldn't be here, but we brought Gervásio to talk about that and to ask any questions about how this process was made. Gervásio, Cesar started with panels. We started with adhesives for plates, and we've done the PIR with high renewable content with BioPur. And Gervásio is an expert since '89 in the first generation of the panels of PIR in Brazil. And he's the one who talked. The first work that we had to develop, good morning. The first work that we developed was through a panel that would be modular so that it could be used in modules. So these modules are 3-meter wide, 6-meter long, and in every 3-meter long, 6 by 3. I can make a house, I can do a lab for a Syngenta company for seeds, to store seeds. Generally speaking, by fiber laminate. The first panel we made was EPS, the first one in the beginning. And EPS, we felt that for the line of houses, it was very hard because of fire, because of IT10. And then we developed PIR, and we made a plant to do the pier block in our manufacturing plant using our adhesive that is also approved by the IT10 standards. What is the next step at Cesar Container for this? Is to use PU green, our foam, our polyol, PU green, for fiber laminate, for us to have all the process, everything based on PU. Apart from the metal structure of the panel, everything in our module will be PU. This is the process. This is the future. Thank you, Gervásio. The next generation is to have more composite materials with high renewable content PU green. Thank you, Gervásio. Thank you, Amilcar. Any queries? Any questions? I'd like to thank you very much. A round of applause.